Right? So chapter 8 is on atoms and the periodic table properties. All right. So first, let's talk about atoms. So atoms are the smallest unit of matter. All right. And it has properties of chemical elements. All right. So within atoms, we have electrons, protons, and neutrons. All right. So the electron is negatively charged, the proton is positively charged, and then the neutron is neutral. All right, so in the center of the atom, we call that the nucleus. All right, so it's a positively charged central core of the atom that consists of the protons and neutrons, containing nearly all of its mass. And again, neutrons have no charge. All right, so on to the atomic number. So the atomic number is the number of protons in the nucleus of an atom. All right, that's the atomic number. It's the number of protons in the nucleus of the atom. All right, so although all the atoms of an element have the same number of protons in the nuclei, the number of neutrons may vary. So it may not be the exact same number that the protons have. Neutrons number may be different. So the atoms of an element that have a different number of neutrons than the protons is called isotopes. So your mass number, this is the sum of the number of protons and neutrons. Right, so once you add up how many ever protons are in the nucleus and how many ever neutrons are in the nucleus, this is called the mass number of that atom. All right, so on to the quantum concept. So in 1900, Max Planck introduced the idea that matter emits and absorbs energy in discrete units called quanta. All right, so quanta is discrete units of matter that emits and absorbs energy. So 5 years later, in 1905, Albert Einstein extended the quantum concept to light. All right, so he stated that light consists of discrete units of energy, and they called that energy photons. So the quantization of energy, Albert Einstein described the energy in a light wave as quanta, so they called that photons. So this is the equation right here. E is equal to hf, where E is the energy of that photon. H is Planck's constant, so this is a number that's constant. And then F is the frequency. So we talked about frequency maybe a chapter ago or two, where frequency is, I think that was chapter 5, I believe. Frequency is 1 divided by the time period of rotation. All right, so frequency is in hertz or seconds to the minus 1 power. All right, then we have the quantum mechanics model. All right, the quantum mechanics model is a mathematical treatment of wave matter. All right, so quantum mechanics, it describes the energy state of an electron wave with 4 quantum numbers. All right, so you have the distance from the nucleus. All right, you have the energy sublevel. You have the orientation in space. That should be in space. Let me say that. And then you have the direction of spin. Now, we won't go into the details of all of that. I'll leave that to intro level chemistry. But right here, we'll just be going over the basic definitions. All right, so on to electron dot notation. All right, so chemical behavior is mostly concerned with the outer orbital of the electrons. All right, so this is where the electrons are able to jump on to other particles if they so choose. All right, so the outer orbital electrons, they have the highest energy levels. All right, so they're conveniently represented with an electron dot notation made by the chemical symbol of the compound or element, and then the number of dots indicating the number in the outer orbital. All right. So an ion, this is when an atom loses or gains electrons. So it acquires an unbalanced electron charge, and that is called an ion. Hard to classify elements like silicon, germanium, arsenic, they have physical properties of nonmetals. So your metals, these are your copper, silver, gold, and then your nonmetals. So that would be your wood, wool, plastic, glass, right? Those are your nonmetals. So the ones that are kind of in between conductors and insulators, they're called semiconductors. So they have the properties of conductors, which are metals. They also have the properties of insulators, which are nonmetals. So that in between category, for examples like silicone, germanium, and arsenic, those are called semiconductors. So they have brittle material that can't be hammered into a new shape. All right, so these elements can conduct electrical currents. And they have the ability to conduct electrical current just like a metal or non-malleable property of a non-metal. So it's a little bit of both worlds. So a semiconductor has properties of both metals and non-metals. All right, so a semiconductor is a little bit of both.